In 11.4, we're going to talk about dividing radicals, which is also called rationalizing. All right, we're going to rationalize radicals. Now, for this lesson, we're going to just assume that all the variables are positive, which means we're not going to mess with that rule about the absolute value bars, taking out of an odd number out of an even index. We're not going to worry about that today. Right now, we're just focusing on what does it mean to rationalize. So let's look at number 1. Let's talk through this. When you have a radical over a radical, you could rewrite this as square root of 20 over 5, all under one radical. Well, and then you can simplify that. The square root of that is 4, which we know that is just a nice even 2. That's fine. But what about like number 2? If we put this all under one radical, 7 divided by 3 doesn't clean up for us, so it doesn't do us any good. However, we cannot leave a radical in the denominator. That is a rule we have to follow. No radicals are allowed in denominators, so we have to rationalize them. And that means to remove the radical from the denominator. So here's how we do it. You're going to multiply this fraction by 1. It's just going to look funny. So what I want to do is get rid of this radical down here. And this is going to determine what's going to make up my 1. Now, it's going to look like this. It's the square root of 3 over the square root of 3. We know mathematically that this is equal to 1, so it doesn't change the value of this when I multiply it, but it will get rid of that radical in the denominator because 3 times 3 is 9, square root of 9 is 3, so it removes the radical. So we're multiplying by 1, but it just looks a little funny. So then we complete this. Under the radical, we multiply. We get square root of 21 over. This is just a 3. The 3's pop out. There's 2 3's and they pop out. Now it is rationalized, and we can move on. So stop and write this rule down. No radicals are allowed in the denominator. To rationalize means to remove the radical from the denominator. So let's look at number 3. Look at this. We need to multiply by something, a 1, value of 1. It's going to get rid of that square root of 5 in the bottom. So let's do square root of 5 over the square root of 5. They match, so it's really equivalent to 1. Now when I multiply just like before, outside to outside, inside to insides, I get 6 square roots of 5. And these 2 5's underneath will pop out because it's the square root. And there's my answer. Let's look at number 4. X squared over the square root of x. All right, we're going to multiply by 1. This one is going to look like this, the square root of x over the square root of x. So now, when I multiply, this is outside, this is into the radical, so I can't multiply those x's together. They stay separate. In the bottom, I'll have x times x, square root of x times x. That means an x will pop out. So now I can look at this. Look, this is an outside, this is an outside. I can reduce this by 1x. That leaves me 1x left on top and the square root of x next to it. I've factored those out, so this is my final answer. Okay, look at number 5 here. Now, be careful because you might want to think, hey, I can reduce the 5 and the 15 and the x, but you can't. If it's this guy's outside a radical and this is inside, you cannot do any reducing like that. Only outside to outside, inside to inside. So I'm stuck rationalizing using what's in the denominator in the radical. Nothing I can reduce there. So I have to multiply by the square root of 15x. When I do the top, I'll get 5x times 15x, straightforward. The bottom, I'll have 15x times 15x. That means it pops out like that. Now that 15x is outside the radical, and I can do some canceling. I can do this. That 5 goes into this 15 3 times, and these x's will go away. They cancel out. So now my final answer will be 15x, square root of 15x over 3. Look at number 6. First thing that jumps out is, look, there's a 3 and a 6, and they're both outside, so I can reduce that 6 to a 2. So what I have now is the square root of 5 over 2 square roots of 3. If I multiply by that square root of 3 to get rid of the radical, I'm now going to have the square root of 15 on the top, and I'll have 2 times, those 2 3's will pop out, right? 2 times 3 on the bottom. So I'll have the square root of 15 over 6, and it's reduced as far as I can go. Okay, number 7, I have the square root of 11 over the square root of 8. Now I want to simplify before I start rationalizing. So square root of 8 is 2 times 2 is 4, which is 2 more is 8, which means I can take a 2 out, right? So reduce before you rationalize, if at all possible. So now I have square root of 11 over 2 square roots of 2. That tells me the only thing I need to do to rationalize is multiply by the square root of 2 over the square root of 2. That will give me the square root of 22 over 2 times, these 2's pop out, so I'll have the square root of 22 over 4, and that's as far as I can take it. Number 8, okay, 32 over the square root of 20x cubed. Well, there's some reducing to do here, right? 20 is 5 times 4, 4 is 2 times 2, there's a pair that can come out. X squared times x is x cubed, right? So there's a pair that can come out. So if I reduce what I have so far, I have 2x times the square root of 5x. That 5 and x are left under the radical. Now, look, I can reduce that 32 by 2, and I get 16. So I'm going to have 16 over x square roots of 5x. Now, to rationalize, the only thing I need to multiply by is the radical portion of the denominator. So I'm going to have 16 times square root of 5x over, that 5x will pop out, won't it? And it'll become 5x squared. All right, there it is in most reduced form. Okay, so we're going to look at some that have an indice of something besides a 2. Like this has an indice of 3, 3, and a 4. So how do you handle rationalization when it's not just a square root? Well, you have to just change your thinking a little bit. So I have to think about this. What can I multiply this by that's a cube root? Cube root means I need 3 of something to come out, right? Well, I have 1 3. I need 2 more 3's to make that happen. So that would make ultimately a 3 pop out, right? So if I multiply the top by the same thing, that's the cube root of 9. So it would be 5 cube roots of 9 over 3. Now resist the urge to do any canceling right here. This 3 is not under the radical. I cannot reduce outside to inside or inside to outside. You can't do that. So resist that urge. You can reduce outside to outside if that had worked. But in this question, it doesn't. So this is where I stop. Let's look at number 10. Okay, cube root of 16. So stop and think. 16 is 4 times 4. I just need one more 4 to make that 4 pop out, right? So I do the cube root of 4. I just need one more. Top and bottom match to make it equal to 1. So in the top, outside to outside, inside to inside, I get 2 cube roots of 4 over, and there's my 3 4's, right? So that's going to pop out. Now I can look at this and go, oh, look, 2 and 4. That 4 will reduce by 2 if I divide those. And you can because they're both outside the radical. So I'm going to have the cube root of 4 left on the top, and I'm going to have a 2 left on the bottom. You always want to make it in the most reduced form. Lastly, let's look at number 11. On the top here, we have 8, and it's the 4th root of 4. Well, 4, break it down, is 2 times 2. I need 2 more 2's to make that 2 pop out, right? That would mean I need the 4th root of 2 times 2, if you want to do it that way, or you can say the 4th root of 4. However you want to do it. So I would say it's 8 4th root of 4 over, now I can go, here's 1, 2, 3, 4, so I can pop that 2 out. Now I need to do some reducing. This 8 and 2 are both outside the radical, so I can just reduce this way. So it's 4 times the 4th root of 4. It's a lot of 4's. Okay. Hope that makes a little bit of sense, and let me know what questions you have when we get to class. Good luck.